Let's now implement list removal. I want to remove the first occurrence of X from this input list. And I would like to get back, I want to receive the resulting list after the removal of X. So therefore, I need to introduce a third parameter for this predicate for the output list. So in this third parameter, I'm going to receive the output list at the end. So what is the base case? This will be really similar to our previous exercise, since basically I need to search for X inside the input list. The base case is when I immediately find it in the head of the list, like this. Of course, I can use the underscore here. And in this case, basically, I'm done. I can return the list without X after the removal of X. So it seems I have to return the tail of the list. So therefore, well, it turned out I need to name the tail of the list and to reuse the variable here. Furthermore, I can stop at this point, similar to our previous exercise. I don't need to check out any further traces, so I can use the cut operator. Okay, so what is the other case? Of course, we need a recursive rule, because if we cannot find X at the very beginning of the list, then we have to keep searching it in the tail of the list. So the next case is when the head of the list is something completely different from X, and I will check out X in the tail of the list, and finally I will return some output list which I don't know yet what it will be. What is pretty sure that this rule is going to be a recursive one because of the iteration I want to execute, and what I want to do, I want to remove X from the tail of the list. After calling this predicate with those parameters, this predicate will return output list at the end, which I receive at this point in this lout variable. And this is the variable I should use when assembling the final result at this point. So how to assemble the final result is easy. I should attach Y to this output list, which I should concatenate them. I definitely shouldn't remove Y from the list, so I need to keep it as the very first element of the resulting list. And this is what I'm doing here. Okay, it seems we are done. So let me just test this code by calling the predicate with a concrete value 1 and with this list. And let's see if 1 gets removed from the list. Well, something is wrong. Yeah, of course, because I passed only 2 parameters to the predicate, although it requires a third one, because in the third parameter, I will receive the resulting list, the output list. Okay, so it seems it's working. 1 was removed from the list. Let me further test it. So let me just try to remove 3 from the list. It seems working. Let me try 5 to remove 5. It's working. And finally, let me try to remove a value which is not part of the list, like 6. Interesting. Well, it's logical, since 6 is not inside the list, the removal is unsuccessful, right? Well, it's up to us if we are satisfied with this result or not, because one can argue if we should keep the list as it is and say that, yeah, the removal was successful in any cases. So let me just check out why this is happening. Of course, as we search for 6 in the list gets shorter and shorter, and finally it gets empty. And where this atom with this empty list cannot be matched with any of those instructions in the knowledge base, this is why we fail in this trace, and this is why we get a false answer at the end. So if you want to change it, if you want to characterize the removal successful, then you have to introduce a new base case for this case with the empty list. This is something we can do easily. So basically, we are looking for X in an empty list. Actually, now we can make X anonymous because it doesn't matter what value we are looking for. The list is empty anyway. And if it is empty, you cannot remove anything from it. So the result is an empty list. This is also a base case. So let me call it base case 2. Okay, now let's run the same query. As you can see, the same is happening. Now we hit the case with the empty list, and this is where the search ends successfully. So basically, we couldn't remove anything. So this is why we keep the list as it was.